Alright, I'm going to move on to today's session. So we left last week talking about energy analysis, and this is just a simple example to show how energy analysis could inform design. And before we get into this, I wanted to mention one thing. 8 years ago, in my final year thesis, my design was to design an educational building, higher education building in Palm Springs, California. And I was able to prove in paper that 70% of the year that building can use passive heating and cooling technologies. And of course, it's a school project, so there's no client. He doesn't have a comfort. I can stretch his comfort. But we do have comfort here. We do have real clients. So it will be challenging, and that's what we're going to look at today. So I just want you to know it's doable, and it is doable, okay? So we looked at energy analysis last week. If you want to turn that off, would you please? Yeah. Thank you. Okay. So the last question on the quiz was to understand these are the several ingredients that go into the analysis tools, and it gives out the EUI. And when we are trying to understand how one piece impacts the EUI, we have to keep the other pieces consistent across the assumptions, because it's too easy to just change a couple of things at a time, because it's so enticing to change it. I'll show you why. Because it's a bunch of numbers, you can change it so easily. But if you change them all together, it's so difficult to understand what's going on. Okay?
Which one had the impact? Was it the lighting or the envelope that you changed?
Exactly. Okay. So I've been thinking about this EUI and how do we rationally approach this? Because we can't necessarily do this on every single job, right? So we have to have a medium. So I can think of 3 ways to attack this problem. The first way is typically most of what our projects will happen, which is we would go with program, function, and aesthetics as our primary importance, and little importance to energy and energy consumption, okay? Because that might be the client's need or whatever. So we may meet the prescriptive requirements of the code, energy code. We have to. So we will do that. But the problem with this approach is, if this is our target, then, can everyone see this clearly? Okay, if this is our target, then your EUI, when you actually find out for this building, could have a wide range. It could fall either too low or too high. You have no clue, because you never tested it. Okay? On the other extreme, there is the radical green approach. You test every single thing that you design. You establish an EUI target, and you examine every single design decision. And then you can compare through your energy model, not energy analysis. You can go to that extreme and compare everything to that SAS. But the problem with that is it's going to consume a lot of time, correct?
Right.
And yes, you can narrow the range, and you'll be a lot closer to where your target needs to be. But this is not feasible on every job. So the happy medium is this one. You use your intuition and your experience. Say for a school in Phoenix, if we found out that masonry wall and tilted concrete sandwich wall is the best performing wall, do you have to do that study on a school in Phoenix again? Okay. So we can use the experience and the intuition from our previous projects, right? And only test major decisions: orientation, shape, fenestration design. Not necessarily go through every single of our design decisions. And by doing that, because since we're using our experience from past projects, we would still be in a narrow range from where the EUI target should be. Do you guys agree that as an approach?
Definitely closer than that first one.
Definitely closer than the first one.
Yes.
But this is something, this energy modeling is optional here. if your project requires to do energy model, you can go and do it. But energy analysis is something you can do on every project using experience. Not every single design decision, but selected few that you have a question. Okay? And so it may look like a lot of number crunching here, right? But what I want to stress here is anybody could do the number crunching. Our competition could do that really easily. But what is important to us is we should have a story. It is one of our 9 principles, telling the story. So what I'd like to propose here is our approach should be from a storytelling approach. If someone asks you, because I've been asked so many times in the past, what is the sustainable features in your building? I say I have a good wall, good roof, good window. Oh, by the way, I have solar panels. That's a very boring story, right? And we don't want to keep telling those boring stories. We want a really interesting story that has meaning to our design. So, how do you develop a story? And what I'm going to go through today is to help you develop this story. So you may have noticed in all these sessions that I'm not actually going through and showing you the button pushing, because that, even though it is important, what is more important is all the why and the reasons behind why we're doing this. The button pushing stuff, it needs more attention. And we probably can't accomplish this in this 1 hour. So we'll do that in another session. So for any story, unlike other stories, our story depends on facts. So it is important to find facts. It's important to first ask the right questions, and then find facts, and then use the facts for design decisions. And then finally, validate a few of those design decisions with analysis. I'm seeing a lot of questionable faces.
Try to imagine the story.
Key items, correct. Do you guys generally agree the approach?
Yes.
Okay. All right. So it's not only architectural, but it's also lighting, systems, and renewables. We have to do this holistically as a story.